Hi, I'm Dario from HTC, and welcome to the Hand Tracking Developer Track. I'll be speaking about the Vive Hand Tracking SDK, which supports several headsets, but will also share some best practices and tips applicable across different hand tracking implementations. But first, I'd like to point out to our developer web portal, which you'll find all of our SDKs and related content, and that's developer.vive.com. On this site, the SDKs are grouped into three categories. Vive Wave, which is the standalone all-in-one platform based on Android. We provide a number of SDKs for developers and OEMs to use this platform. Vive Port, the distribution platform, and SDK supporting DLCs, in-app payments, DRM, and much more. And the Vive Sense category, which maps to our senses, eye and lip tracking, audio, and hand tracking. Back in 2015, when I started showing demos of the original Vive, a number of users new to VR were so immersed that they placed both controllers in one hand and tried to reach out and interact with virtual objects with their bare hand. Now, we can finally do that, using hand tracking to interact with objects. And when you add audio and visual feedback, the lack of haptics can be compensated for as our brain uses proprioception to give us a convincing sense of presence when we do reach out and try to touch or even punch things. Here's a basic use case for hand gesture recognition. This sample demo illustrates interactions directly with objects and remote interactions such as remote grabbing with the use of single and multi-hand gestures. The sample project shown here is included with the SDK along with full source code. Our Vive hand tracking solution, like others, is a deep learning-based solution. It can track both hands simultaneously, distinguishing the left and right hands, and can currently recognize up to 6 predefined gestures. And recently, we added the ability to use a pinch gesture. The hand tracking engine can provide hand positions available in both 2D and 3D point modes. And there's a skeleton mode, which is essentially finger-level 3D positional tracking consisting of 21 points on each hand, 4 per finger and 1 for the palm. The 21-point skeleton can be mapped to a custom hand model, of which we provide a couple of examples. In this use case, hands are tracked with a green screen background for a composite using ghost-like transparent hands. Technically, you could also use the pass-through cameras to show the real world and handle virtual objects with your visible hands. Hand tracking can be used in VR, AR, or more precisely mixed reality. In case you may not have heard, we even support the original Vive, as well as some Android phones. This chart here shows you which modes are supported per platform. As you can see, the original generation Vive headset only had one camera, so it doesn't support 3D positioning. However, it does support gestures. We will also be adding additional headsets to this list. And here's what you get when you download our SDK. On the right is the zipped up package containing support for Android, Unreal, and native C, C++. We have full online documentation and the latest Unity package. On the left are some of the release notes for the current release, which introduced pinch support, but for the thumb and index finger only. It's not really necessary to support more than one combination of fingers for pinching, only the natural one, which is intuitive. For the most part, err on the side of natural interactions, rather than anything that requires a tutorial or hints. All development platforms are supported equally as far as the scope of the APIs, which consists of basic core functionality very similar to other hand tracking solutions, namely pose and gesture detection. The Unity and Unreal plugins essentially wrap the native C, C++ APIs. With the Unity plugin, you'll need to add the gesture provider script to the render camera. The script handles start, stop, and pull results automatically, and hand detection only runs when the script is active. In Unreal, you'll need to add the Vive hand tracking component to your scene, which provides the blueprints equivalent. The recognition engine doesn't necessarily start immediately, so it's useful to check on the status with this API, and of course to check for any errors. You can obtain the left and right hand results directly, usually from your main loop. And you can also check to see if there's been an update in the currents frame to avoid any additional processing if there hasn't been an update. Here's another basic use case: drawing or potentially sculpting with your hands without controllers. Again, gestures can help toggle between different drawing or erasing modes. Here's an application available on Viveport, illustrating 2D or 3D point modes without having to show the hand. Note that the gestures here are point-based, much like when we detect gestures with controllers, meaning it's calculated in your application versus being natively recognized. Also note use of the pass-through cameras to recognize marker codes to dynamically show new content. Use of the skeletal mode mapped to hand models will make it more intriguing and immersive, so do import existing or create custom models for use with hand tracking just as you would with controllers. In Unity, we provide a model renderer script that will take care of mapping the rigged model to the gesture results position values for each hand joint. Here's a set of guidelines for artists and developers when creating skin mesh rigged models. I'm not going to read all of this list, but you can see there's some specifics for rotation and axes of the fingers, and specifically the default state of the hand, which should be all fingers open. I found that some 3D tools may require some specific tweaking when exporting the FBX file for use in Unity. Just make sure it can create a skin mesh renderer upon import into Unity. So let's review a step-by-step getting started from scratch in Unity. As I previously mentioned, simply add the gesture provider C# script onto your main camera. Next, add the model renderer script to the hand model object, making sure nodes match the corresponding joints of your rig. And also note you may specify the mesh to use from the FBX right above the list. And also note the collider type at the bottom that this script uses to create colliders for you for each of the joints. Otherwise, you can also create the colliders yourself. And here's where you handle or manage specific gesture recognition and the corresponding event action to take with this sample hand state checker script. Note that this can handle two state conditions, a prepare condition and a trigger condition. For example, aim and fire. Optionally, you can also specify a reset condition, for example, when you lose tracking. Here's another view of the sample project. Here we can see how to use a gesture to toggle between models, but also showing interactions using the model's colliders as well as how to pick up something with a collision trigger event while also using a gesture to indicate a grabbing intent. And in this case, we're using the OK gesture to initiate a grabbing mechanism. Now, when grabbing in VR, you're probably aware of how similar this is to how it's implemented with controllers. Here we're illustrating what it means to rely on colliders versus colliders and gestures. To illustrate this further, you can see here how difficult it can be to pick up a tiny cube with colliders alone. This is why you should consider the options you have for grabbing when using hand tracking. Try combining existing solutions or come up with new ones to make it appear seamless rather than just relying on colliders or default physics alone. Now earlier we saw how we can grab things remotely. Here's another way you can use a gesture, in this case the pointing gesture, to turn on a laser pointer to remotely select menu items in a standard Unity UI, where normally you would use raycasting with controllers. Simply repurpose your raycaster to emit from the tip of your index finger rather than a controller. An example of a natural interaction would be to use a poke gesture to initiate a remote button click, much like pressing a button when using colliders for near interactions. Okay, here are some tips I learned while implementing hand tracking. Don't assume 100% accuracy to avoid additional work, and assume physics alone will make it look realistic. Don't assume ideal lighting conditions or not going out of field of view. So do use the new confidence feature. And how we saw earlier, don't leave it all up to finger colliders on their own. Also consider using IK, for example, with an invisible arm to maintain the wrist position. Do consider also adding animations and or customize colliders in combination to gesture recognition to trigger state changes. Maybe even dynamic colliders as well for those use cases that require better grabbing or perhaps in combination with snap-on mechanics. Use natural interactions. Try falling back to position-based gestures as done with controllers. For example, swipes, pokes, circular motions. Reuse your controller code for interactions as much as possible by abstracting as much as possible. In these experiments, I've reused VIU, the Vive Input Utility Toolkit, for cross-platform development. Another way to handle remote raycast UI interactions is to morph it into a near-based one, resizing the menu and placing it by your hands, or pull it out of a hand, so that you can use near interactions with colliders. Or switch between near and far interactions depending on the recommended distance of about 0.25 meters. And similar to how eye tracking can fall back to a headset-based gaze, or how audio should fall back to subtitles, fall back to controllers, or fall back to hand tracking to account for cases like bad lighting, dying batteries, or for accessibility reasons. Play with scale and position. Make it magical. Surprise with the unexpected. Our next release is coming in July, and in addition to ongoing improvements in performance, features include custom gesture support and Valve Index support. Additionally, we're supportive of and a member of the Khronos OpenXR group, which recently announced an OpenXR extension for hand tracking. So please give it a try and give us your feedback. Here are the direct links, but you should be able to easily navigate from developer.vive.com. In addition to the above resources, I'll be posting additional code on GitHub. Simply search for Vive or Vive software on GitHub. We have a dedicated forum for hand tracking, frequented by our hand tracking engineers. So if you have a question, post it there, or feel free to reach out to me directly. Thank you.